So this video is our last of 3 videos about stacks. So in part 1, we talked about what is a stack, some things we can do, the basic operations of a stack, and we created an abstract data type for stacks, okay? In part 2 of the video, we talked about implementing stacks using arrays, the regular array feature of C++, and we went through the code to do that. In this video, part 3, we're going to talk about implementing stacks as linked lists, okay? And for that, I'm not going to do any coding, but let's talk about some of the concepts here, okay? So again, just to familiarize ourselves, and I would go in order, certainly. We have our stack, we have the items as they go in, and the things at the bottom. So if we had 1, 2, 3, 4, so we push 1, push 2, push 3, push 4. At this point, all we can see is at the top of the stack. Again, this is the top, this is the bottom. Okay, that's all we can see. We don't know how many are there. We can't do anything about that, but we can push a new one on. We can look at what's there at the top, or we can remove the top with a pop. So 1 pop would remove that, and 3 is now at the top. Okay, so that's the basic idea. So the way that we can do this with a linked list, okay, is that we would start with our root that points to an empty linked list. Okay, we add our first item, we add our 1 here. Okay, then we have that 1 item, that's the top. Okay, as we add a second item, okay, so we add, and this is going to be an add to front. Okay, we can always get to the first element of the linked list, the root element. So the root element is going to represent the top. Okay, so this would be if we did a push 1. Okay, now let's do a push 2. Okay, we would do a basically insert from front, a new node, okay, which has a 2. We would then link up this one to that one, okay, and then move node back over to that one. Okay, so after that push, in essence, you would have 2 root points to 2, which points to 1. Okay, basic enough. Okay, if you wanted to add a push 3 to make it look like the one over here, okay, a new node with a 3 that would point to there, the root would reroute to there, and we have, in essence, this would be equivalent to the root points here, that's the top. You have the 2 points there, which points to the 1, which is at the end. Okay, so these are equivalent representations of the same idea of a stack. Okay, so as far as the top goes, okay, if you look at root data, or info we call it, whatever you call it, we've been calling it info. Root info is going to be equal to whatever's at the top. Okay, so top will return root info. Okay, a pop is just going to be a delete root. Okay, which is pretty basic. It's going to be a root is equal to root link. Okay, so if we do a pop up here, root would just point to that one. Okay, that would be it. Okay, so that's the basic ideas. In this case, our stack top we can use instead of root. Okay, we can call this, whenever you see a root, just say stack top. When you create a version of linked list to store this, that's just fine. So all these become stack top. Okay, makes it a little bit clearer there. Okay, so our constructor just sets that equal to null. It doesn't point anywhere. Okay, the is empty stack. Okay, so the is empty. Okay, it's just going to return this Boolean is the stack top equal to null. If it is, then it's empty. If not, it's not. Okay. The is full stack doesn't really have any meaning, right? Because as long as we have memory, which we're probably not going to run out of memory, you can keep pushing as many items as you want. Okay, so the stack doesn't really have any limit on that. So on the is full stack, you just return false. That's all there is to it. Okay. So if we're going to initialize the stack, okay, we have to think about this. We have to make sure, and we've done this in dealing with our linked list before, you want to make sure that you're deleting all the elements of the stack. So you have to go through, set a temp, delete them, all that stuff, okay, to make sure you're really getting rid of them. Okay. And that should be it. I mean, there's not really much there. We do need a copy, the copy stack function, which we can use in overloading the equality operator and for the copy constructor. But beyond that, that really should be it. Okay, I mean, this is kind of a short video. It's shorter than we normally do because we're not going to go through the code. It's going to be an exercise for the viewer. Okay, so I think I will talk a little bit here about why you pick one over the other. Okay, and there are lots of reasons. Okay, so if we just want to do, you know, array versus linked list. Okay, on the array side of things, I think you can argue that it's probably easier to program, easier to think about. Okay, so that's one thing. So on the linked list side, it's a little more complicated, especially the memory management or garbage collection. Let's get a little more complicated. Okay, the linked list is more flexible. Okay, so it's not a fixed size. Okay, so those really are the main differences. Beyond that, there's not a lot of difference as far as that goes. Okay, and then I guess to finish this up, we can go back to why stacks to begin with. Okay, so one more. There is a disadvantage in here that since arrays allow random access, you have to make sure your code doesn't. Okay, so you have to not allow that to be manipulated like a normal array. Okay, so why stacks to begin with? Okay, so stacks are useful when you want to enforce a particular ordering of things. Okay, so again, we often use stacks internally in the operating system when we're doing function calls. Okay, so if your code is going to call F1 and then F2 and then F3, that's not correct. We're going to call F1. Inside of F1, it calls F2. Inside of F2, it calls F3. And F3 is going to call itself 3 times. Okay. So the stack here is, it will start with our main program. Okay. And the code pointer, or let's call the code, the line pointer, whatever it's called. Anyway, the code execution marker will be in main. Okay. We call F1 in a stack. It's there. F1 doesn't close, it calls F2. So it's there on the stack. Okay. F3 calls itself 1 time. It calls itself 3 more times. For a total of 4. Okay. So all of these are stopped or temporarily. They're paused, let's say. Okay. When this one exits, so this is active. When it exits or closes, okay, where does the control go back to? It can only go back to here, okay? So because it's implemented as a stack, there's no option for any of these others to be moved back to. It's got to go back to this one, okay? So that's a good use of a stack, okay? We also use stacks for other things. We can use a stack if we want to reverse something. Okay, if you put things into a stack and pull it back out. So if I do a push 1, push 2, push 3, and then I do a top followed by a pop, followed by a top, followed by a pop. Okay, I'm going to get a 3, a 2, then one more time, I'm going to 1. Okay, so I've reversed my stack. Okay. The other thing we can do with stacks would be parentheses. Okay, we can see, and there'd be other stuff in between there. We can see, are these matched? Okay, the basic way this would match is that an opening parenthesis, opening mark, whatever it is, we've got square, curly, and parentheses. An opening mark pushes something onto the stack. Okay, so if we have, here's our stack, we have an opening parentheses there. Okay, we then have an opening parentheses there, an opening parentheses there. Okay, we see a close parentheses. If it matches the opening one, we take that off the stack. Okay, another close there that takes it off the stack. An opening square bracket goes onto there. Okay, an opening curly bracket goes onto the stack. Okay, ignore everything else, get to this one, take care of that one. This one says to pop that off. That says to pop that off. Okay, so if you end with an empty stack, then you have balanced parentheses. Okay, and if not, if you got one left, then you don't have to write it. Okay, the other time you sometimes see this if you're doing something with like the orders of operations in like a reverse Polish notation. Okay, or in when you're not doing the normal way we do math, but when you're doing it like instead of 1 + 1, you're doing 1, 1 plus, or plus 1, 1. Okay, and with this case in this form, okay, it's called prefix operations. You would in the stack, actually this way, you would start by pushing the 1, then the 1, and then when you hit the plus, you would bring back everything from the stack and perform that operation on it. Okay, so those are just some basic operations, okay, that we can do with stacks. Okay, so hopefully these videos have been instructive and it's made sense what it is that we're trying to do here. Okay, so if you have questions, make sure you let me know.